Hi, this is lesson 12 in the use of JASP. Today we're going to talk about how to transform variables using synchronization with Excel from JASP. So let's get started. I'm going to go my three bars, open, go to computer, go to JASP data for videos. And previously we were working on this data set called Bank Rev 05. I have a second one created here that's basically a duplicate of where I left off from lesson 10. So I'm going to go ahead and open that. In lesson 10, we learned how to document, that is, provide labels for variables like sex or gender, job category, minority status. And we looked at how when we treated beginning salary as a dependent variable for a t-test, that it violated the normality assumption and it violated the homogeneity of variance assumption. We looked at some ways of accounting for that with the Mann-Whitley U-test and Welch's correction. But another way of doing that, of dealing with those problems, is to transform the data. And so today, what I want to do is to talk about how do we go about transforming that data. And what we're going to focus on here is the use of what's called the ladder of powers. This is just a portion of the ladder of powers, but the basic idea is that if you have a right-skewed data set, for instance, drinking behavior, where a lot of people might have 0 drinks in a week, 1 drink, 2, 3. So you expect on the low side of drinking to get a high frequency of people on that side of the distribution. But as it stretches out to the right-hand side, that's my right-hand side, and that you're going to get fewer and fewer people who have extreme values, like 20 drinks in a week, 40 drinks in a week, 100 drinks in a week. What if someone's reporting 100 drinks in a week? What do? Well, you can do things like a square root transformation, for example. This is where you take the original score, take a square root. So if someone had 36 drinks in a week, that brings them down. Square root makes it look like it's 6. The 100 drinks in a week becomes 10. And now the difference between 6 and 10 is not so large. It tugs in the values on the right faster than it tugs in the values that are in the low end of that scale. The natural log, or the log base 10, will pull that in even more so than the square root transformation. And so you get values like 36 becoming a 3.58, 100 becoming a 4.05. There's also a ranking transformation that can be used where you take numbers like 3, 25, 36, and 100, and you just give them a rank. Say the lowest is a 1, the next is a 2, the next is a 3, the next is a 4. There's also transformations where you take the reciprocal, that is 1 over the original value. So 1 over 36 or 1 over 100. This has the oddity of flipping the scale, making a person who has a 36 drinks to have a larger value than someone who had 100 drinks, but you can correct for that by multiplying by -1. And there's also the reciprocal of x squared. So 1 over 36 squared, the caret is, stands for squaring the 36. Again, transform that by multiplying by a -1. Well, I'm going to show you this in practice. How do we do it? How do we manipulate our data that is in JASP by using the edit function. In the previous video, I showed you how to add computed columns in JASP. Today, I'm going to click on the edit button, and then I'm going to say I want to synchronize and open the data file, and it opens up an Excel file. And here I'm just going to go ahead and I'm going to create my new variables. So I'm going to create the square root of Salbag. I'm going to create another one for the log. So I'm going to do ln for natural log of Salbag. I'm going to do one for the rank of Salbag. Salbag is beginning salary. I'm going to do one for the reciprocal of Salbag. And I'm going to do the reciprocal squared of Salbag. Now, in that first row, I'm just making up a name. It could be Tim, Juanita, Jerry. It could be whatever you want, but these give me hints as to what I'm doing here with the name. So let's go ahead and create these. We're taking this variable here in column H, and we're transforming it. So my first one, I'm going to do equal, then I'm going to say square root, SQRT, open a parenthesis, move my cursor over to H2, hit Control, and now that number is the square root of salary beginning. And you'll see that I'm going to be able to essentially copy and paste that and get that for everyone, and I'll go ahead and take it all the way down in just a little bit here. For the log, I'm going to do equal ln, which is for the natural log. You can see on the command there, it's saying returns a natural log of a number. Open paren, go over to my variable salary beginning, and you can close the paren or this hit return and it closes the paren for you. And that number now becomes a 9.69. Ranking is a little bit trickier. I'm going to do equals rank. And of this number, but then I have to tell it what numbers it's choosing from. So it's a rank out of these numbers as my reference. And that gives this score a 300. Now, a problem with ranking is that traditional ranking would be a 1 is in first place. I know that there's someone here with a really high score here. That is a high salary. 72,000 is one of the highest salaries of people in this company. And so let me go ahead and copy and paste that command. Yeah, they're the second highest paid. But I want my numbers to be in the same order that they began at, which means that I want smaller numbers to be the lowest salaries, and I want larger numbers to be the higher salaries. There are 475 people in the data set. If you go down to the bottom, you notice that we have actually 474. There's 474 people in the data set. I'm going to add in a column, and I'm going to go equal 470 equal 475 minus that number. And that's going to flip the scale by taking the largest value minus this number. And I'll just go ahead and call that RK, Salbeg. And now that you see that the person who had 72,000 is now has and had the second largest rank, now has the second largest number of 473, where the highest would be 474. So now it's in the same order that it was originally. Let's do the reciprocal. That's going to be 1 divided by my score times a minus 1. But when I do that minus 1, you notice that it gives me an exponent. You know, you can, the exponent is fine. You can analyze that, but you could, what I like to do is to add zeros. There we go. And now I've pushed the decimal point back to the left so that it gives me a number that I don't have to interpret as an exponent. I'm going to do the same thing for this next one. I'm going to do the reciprocal, but it's of this score squared. And to square it, we do a caret and then a 2. It's going to square the number. Then we're going to multiply minus 1. Again, I get an get this in scientific notation where there's 9 leading zeros or 8 leading zeros before the number there. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. One more. There we go. And now I've shifted the scaling. So the transformation remains the same in terms of what it does, but the scaling is now different. Okay, I'm going to take all of this and I double clicked on the bottom right and it copied those formulas all the way down. And so I've manipulated my data set. So there's some basic commands in Excel for manipulating your data set. Importantly, they go to manipulations that are going to change the scaling of the variables. In the next video, we're going to actually look to see how those variables can be used in statistical analysis. But we're not done yet here. Let's get back to where we started. And I'm going to save. And hopefully when I go back, there we go, turn it down. Those variables are now in my JASP data set. So one of the nice things about JASP, the easiest way to manipulate your variables is to simply go to Excel and do your manipulations there and then just come back with it synchronized to your JASP data set. Now I'm going to go ahead and save as on my computer and save this as version 2 and replace it. And so now this JASP data set exists in the system and it's ready for our next rendezvous. We'll see you in the next lesson.